Next, we want to get a little bit more technical and define a definite integral. So we have the definition of definite integral. If f is a function defined from a to b, we divide the interval a to b into n subintervals of equal width, delta x, which is b minus a over n. We let x sub 0 equal a, and all the way up to x sub n equal b are the endpoints of the subintervals. And then we can take any sample point in the subinterval. So x1 star would lie within that first from x sub 0 to x1 interval. So x sub I star would land in between the x sub I minus 1 to the x sub I interval. The definite integral of f from a to b we write as this, and we say it's the definite integral of f from a to b. That is equal to the limit as n approaches infinity of the sum from 1 to n of f of x sub I star times delta x. Again, we can kind of think of this as just a base times a height, because the base, that is a width, and that is a function height, provided that the limit exists and gives the same value for all possible choices of sample points. What this part is saying, all possible choices of sample points, that says that we can use left endpoints, right endpoints, midpoints, upper sums or lower sums, and they all should give us the same solution. And if they do, then it's called the integral of f from a to b. If this does exist, and if we can evaluate this, this should give us a number as an answer. We say that f is integrable on the interval from a to b. Okay, so you may be asking, well, what can we find the integral of, and what are some words that we'll need to use when talking about this? Well, let's talk about some words first. The a and the b are called the limits of integration. The f of x is called the integrand. The dx tells us the variable that we are using in this problem, the independent variable. And really, it's part of the symbols. This is all one. We take this all to mean one thing. All of that kind of goes together. We've got the integral. This is the start of the process, the function, and then that's where it kind of closes it off. So then you may ask yourself, well, what does it mean for it to be f to be integral? Well, if f is a continuous function on a, b, or if it only has a finite number of jump discontinuities, remember jump discontinuities look like something like that, then f is integrable on a to b, and then we can find this definite integral from a to b. And if we can do this, then what we have, the definite integral, is exactly equal to what we defined in the last section. This is just the limit of the sum using right-hand endpoints. Notice if we start at a and then go from 1 to n, this is just right-hand endpoints. Our delta x, that's the width of our rectangles. So really, we're just thinking about it in terms of base and height. So what do we want to do? We want to express this limit of this sum as a definite integral, and then we're using from 0 to pi. So the answer is, this is the integral from 0 to pi of the function. Well, what is the function? The function is x cubed plus x times the sine of x dx. That's it. That's all we have to do. Now, we don't know how to evaluate this. We don't know what this equals, but it equals some number. So we would like to be able to evaluate integrals and find what does this number equal.